Reasons for version control. First, why we should use it, what are main terms, what are most popular ones, and then in practical exercise we will check how to use it. So this is overall project life cycle. We will go in details about it later. We will mostly talking about implementation, but of course real project starts with analysis and design, then you implement, you build it and package it and deploy it, and then you test it and then you continue. But particularly into this implementation and building part, collaboration is very important when you start working on more complicated projects. When you work on trivial project, it's not so important, but it's very important when you start working in teams. And if you have distributed team, like we have here, distributed class, question arises here, how can we share this knowledge and how we can share this progress between different members to get different updates. And one of a hard way to do would be to use general sharing service like file sharing, because any development project consists of many files, and usually you change only some of files from all of the files. And if you use file sharing service, then either you need to share very independent files, or if you share entire folder of your project, then everybody needs to investigate what's inside in this folder, what was changed, what was not changed, and it is very hard. And therefore, when you work in a team, what you usually do, you use specialized version control system, which also allows you to share files, but it takes care about tracking these changes and comparing what was changed between different members of a team automatically. And that is very important, that you do not lose too much time on management, on collaboration with other team members, that you still mostly can work as a developer, you can still mostly write your code, and you do not spend too much time to synchronize your effort with other team members. And other important part is that even if you are working alone, version control system still is very useful, because it provides you backup of your project. Of course, again, you may use general backup tools to make backups of your project, either some more specialized backup tool, or you just create archives with some naming convention for your project from time to time. But again, problem here is that then you have to spend quite a lot of time not with coding, but with managing your backups and comparing them. So version control systems allows to do you two important things. First, to collaborate efficiently with other members in your team. And by efficiently, it means you don't need to spend too much of time to get updates, to compare changes, and to submit your own changes. And it also allows you to store backups of your project efficiently, so that you don't need to spend too much of time thinking and managing these backups for your project. And then later we will also discuss the thing how you can do parallel universes or branches in your project, that for some reason sometimes you may decide to not work on absolutely the same project, but on some kind of clone of your teamwork project, where each of these parallel universes or branches of your project has some small little differences from original mainline version of this project, but we will investigate these parallel universes or branches a little bit later. So all version control systems allows you to make backups as different versions of your files or entire project, which may be called revisions or which are confirmed by commits or etc. They allow you to add names or tags to particular place in history of this project. Some of these places in history of project may start these parallel universes or branches. We will not go in details about this. They allow you to see differences and merge different sources into one single source quite efficiently and quite easily. And which product you should use if you have free will and free choice? I recommend for you to look only on 3 different systems. If you need centralized version control system, which still has some nice features because centralization is easier to manage, then I think leading standard would be Subversion, which is also shortened to SVN. So executable file for Subversion is just SVN, which is open source and centralized. And then from decentralized ones, the leading standard is Git, which is de facto standard for almost all open source projects, what I know. And Mercurial, or HG as a name for its executable, is also distributed but a little bit simpler and more developer friendly than Git. And what you shouldn't use is version control system called CVS from concurrent version control system, which is free and open source, but it's very old and not developed anymore. So you shouldn't use. We used CVS almost 15 years ago in Exygen, and we moved projects from CVS to Subversion at that time. And then there are some proprietary closed source version control systems like IBM Rational Clearcase, Perforce Helix, and Microsoft Team Foundation Version Control Server, or TFVC, which are also quite old and centralized and closed source, and you shouldn't use them. For example, especially Microsoft Team Foundation Version Control System shouldn't be used because Microsoft itself doesn't use this system anymore. For example, if you think about biggest Git repository in the world, do you know what it may be? Some may say that it is Linux kernel, but it may be the most popular Git repository in the world, but it's not the biggest, because if you Google it, I think it's still true. Because last time I checked, largest Git repository on the planet is Git repository for Microsoft Windows operating system. So Microsoft switched 4 years ago from their Team Foundation version control system to the Git repository to make them more efficient to develop Microsoft Windows operating system and all its different clones. And even if Microsoft doesn't use such system for their needs, and even if Microsoft switched to Git for their biggest source code repository in the world, then I think you also shouldn't use anything other than Git in most of cases. And that's what you need to learn. Now a little bit about vocabulary or jargon or terms. So place where your project, your source code is located is called repository or repo in short. You shouldn't translate repository in Latvian as a repositories. It is very long and ugly word. In Latvian, repository is krātuve. So in Russian would be something like хранилище or something like this. Then you may add different kind of these snapshots in history of that project, and depending on jargon and naming convention for particular version control system, it may be called revision or version. So each particular state which is stored in this repository is revision. Then, depending on type of version control system, you check out it or clone. For example, if you use SVN, it is centralized. You have one repository on server, an SVN client, which interact with the server. Then you check out when you do in this direction, and you check in when you do from your workstation to the server. If it is distributed version control system like Git, then you have a remote repository, and then you have a local repository. Then you clone them and you make a local copy of that remote repository. And then you can do different kind of changes. You can add these changes into a particular revision or change set, and then you confirm it or commit. And again, here are differences. If you have a distributed version control system, then commit means just update your local repository. But if you commit something on a centralized system, then you confirm and send this data immediately to the server. And then you may have conflicts when you start working in a team. We will deal with this later. Then you can fetch, pull and update and revert undo changes. Manage manual. These will be advanced things. So what I will show you. So this is how centralized version control system looks in general like SVN. And this is SVN commands. I will not go into details. And this is how distributed version control system like Git and Mercurial looks like. You have some remote repository, you have local repository at your computer, and then you update to make your working copy, commit when you update repository, and pull and push, actually fetch and push to update the local repository with remote repository. What is working copy? Working copy are actual files and folders. For example, in our case, local copy for our project would be this folder, U00 for me. And now a little bit about these commands. So here we see lifelines of different objects in Git version control system. So time starts somewhere here in top and continues somewhere here in the bottom. And you have lifeline of remote repository, which may be GitHub. If it's very public, it may be some repository in your company, in internal network. Then you have local repository, usually located in .git folder, another .dot folder, or hidden folder inside your project, and then workspace are actual files and folders on which you are working inside your project. And then there is a scratchpad or internal buffer where you can remove or add something into index, which means list of files or folders which needs to be updated, either from your workspace to local repositories, then you commit it, or if you, for example, reset it, then you reset your actual files and folders in workspace from local repository to your workspace. So you undo some changes. For example, you did some test, didn't work out, you reset it to some previous version. And so most important commands are following. When you synchronize a remote repository with local one, first, usually you start with cloning a remote repository to local repository. That's how you do, for example, when you collaborate through the GitHub or whatever. So it is created through web browser, cloned, and then you can do some changes. You add these changes to the index, you commit them, and then you push back to remote repository. If you work in a team, then you can fetch and then either merge or rebase, or you can do git pull, which means either git fetch and git merge and git fetch and git rebase, depending on your default settings of git configuration. And then there's another lifeline of git database, which is not synchronized with remote repository, called stash. It has the same lifelines than your local repository or remote repository, but it doesn't have any relation with history of these two repositories. So in stash you can do your own version control for different kind of steps and stages and tests, where this list of commits, this history, will not be in any relation with history of these repositories. Local repository and remote repository are quite exact clones. There always may be differences. Remote repository may have more branches than your local repository. Your local repository may have more branches than remote repository. But if you do not care about branches and do not count how many they are in one side and another side, then for a particular branch, history is always the same, except some unsynchronized changes in history which you have made recently and you have not pushed and fetched with remote repository yet. So that's about basic lifelines and commands. Any questions or comments so far? If no, I hope initially you have enough experience to start using Git version control system, and we will go in more details when we will actually need these details. That will be closer to the end of these individual exercises. And because I have not talked too much of time, maybe we can also join theoretical part together with the practical part. So to get results of your exercises and to test them on my computer, we will using Git version control system. So in general, this workflow will look like this. There are many your computers somewhere in the internet. Then will be Git repositories. What's that? So many your computers or your projects, if we ignore everything else. Then we will have Git server with many Git repositories. And then there will be my computer. So these are your computers. And you will push your projects to this server, and I will pull them to several my projects. And I will test what you have done through this collaboration of version control system. So you will be mostly pushing, I will be mostly pull through this server. So I will never check what exactly is happening on your computer, and we will check what exactly happens in your computer if you will need specific help and advice. But otherwise you will put your progress on the server and I will get it back. And this workflow is a little bit different than you get used to if you have enough experience, because leading standard, how you collaborate using Git version control system is through the GitHub, but it is a little bit different because GitHub is not Git. GitHub is web portal which first has nice web interface, and you can always create new repository just through the web interface. And then what you usually do, you clone it, this is too verbose, because a repository is already created. I can use something like this. And then I can let's change HTTPS to SSH. Okay, I will not go into details here, but you got the idea. Or, yeah, I need to check what was my password if I use HTTPS protocol then. But instead of this workflow, which may be already known to you, for privacy purposes and security purposes, we will do it a little bit differently. Our remote server will be specific server which we may call bootcamp server, or bootsa server, or tools.odo.lv. So I think that these commands are already completed for us, because as far as I remember, this was part of setting up operations for our workstation. But what is not done is these settings. For example, it was done for me in this workstation. So if you do not have, for any commit you do in Git, you have to add 3 additional, parameters, information bits about your commit. One is commit message, and if you do not pass commit message working in the command line, text editor is opened and you can write something into this text edit. So message field, and then username, which user has made this commit, and email. Message field usually is unique for particular commit, so you do not set it as a default setting what would be default value for message, but your username and email usually do not change. You may have changed, for example, for security purpose working in different projects. So sometimes you use your Gmail account, sometimes you use your Accenture account or IBM account or whatever. But in simple life scenarios, you usually have the same name and surname and your email, and therefore you can set them as a default settings in global settings. And in command line, you do this in following. And then also set your email as a and here we have to wrap it inside the quotes or double quotes because it contains space. Here we don't need because it doesn't contain. And all these settings are stored into so-called dot file, .git config here. So when you execute this command, following keys are added into this configuration file. And then default setting for Git is that if you do not pass message value for commit, it opens text editor, and text editor which is opened is VI. Actually Vim has a VI improved, but if you are not familiar with Unix-like systems and systems administration, you may not know this editor. Actually you should know it because it's very useful, but for your virtual workstations you may set that your default text editor, if it will be needed, will be mousepad instead of VI. I will not use it because I'm not afraid of VI. I'm actually using various editor. Here I use graphical Vim or GWIM, work in foreground mode, so I will not change that. But you should do this. And then we will say that compression tool and merging tool, if we will need one, will be nulled, which is one of quite popular compression tools in Linux-based operating systems. So that is preparation. We need to do 3 steps. One is configuration. Let's say global config. This is done. at least for me. Then we need to connect to this remote server and create repository. That would be second large step, and third step is create link between your project and remote repository. When you start with cloning some remote repository, you immediately and automatically create link from your project to remote repository, because when you clone it, you know where this link to this remote repository is. But because we have already existing project, we do not want to clone something to empty project. Of course, we could clone it and then copy all the data from one project to another, but it is just moving complexity around. So instead of a nice web interface to create this remote repository, we have not so nice text interface using SSH. And SSH is client to connect remotely to the different server, to remote machine, and it is a virtual terminal as a window to another computer. When you open local terminal, you are seeing your own computer through the glasses of this text terminal. But when you do SSH, first you can check that your computer is configured and it knows what boot server is. If for some reason it doesn't know, and you can live with this, you can also use server with domain name tools.odo.lv. So it is, if your virtual workstation is properly configured, it is the same. If bootse server for some reason is not known, then everywhere you see bootse server, you actually can use this domain name here. So you need to do SSH connection to it with your given user ID. And password is, let me check what the password was. Initial password for this user is Java BC, capital J, capital BC, dash or minus 2021 dash and your identifier. So x6 should be your actual code. So, and that's not how it looks. For you it will look a little bit more differently. Okay, I will just so first you say following message, which says that you are about to connect remotely to this server. Its IP address is following and fingerprint for its public key is following. So for encryption it uses public private key infrastructure, and if you are careful, you should check that this is that message. If you see this is as different, it should be man in the middle attack. So here you have to write yes, not just Y or just enter. And then you write your initial password where it was here. Java BC 2021, you blah blah blah, delimited with dashes here. Now this terminal here is window to remote computer. If you look here, you see that here I am Valdis on Xubuntu, and if I check who is on this computer, there's only Valdis on this computer. But on this remote terminal, I see that I am user U00 at server tools. And if I check who, I see that there are several other users connected to it. So everything now I'm doing through this terminal using SSH is actually happening on remote server, either called bootsa server or tools.ado.lv. And first thing what we need to do is we need to set initial password to something different. So we enter command password, not password, but shortened one. Enter current password. And I will not change it because I actually did it already. So in that way you know that your remote repository is secure and nobody else will be able to look on it. And when it's done, then we actually need to create this remote repository. First we create folder with our user identifier. And then we change it as a current directory, and we say git, and this --bear is important because such repositories are not synchronized with workspace, and how do you deal with branches is also different. Remote repositories are usually bear. When you create this remote repository on GitHub, it's also bear repository. And then you can say exit, and pay attention here that when you write exit, again you are different user on different computer. So now this terminal again shows you window on your local computer. So I have done this second part. Let's check some progress. So this is done, at least for me, and this is done. And now I need to set up and create link for this my local Java project with remote repository. So I go to my workspace or whatever is place where my Java project is located. So current folder is my current project, or you can always check what your current folder is. And here I say git init, but not as bear, but proper full repository. And then I need to add link from my local repository to the remote one and be careful here. I have to put my identifier in 3 places of this URL. First one is what user will be used to connect to this remote server user 00 for me at bootsa server. And then location, this is a home folder for this user, /home/uu, but because we will have two different repositories, the same subfolder inside home folder as a repository for this Java project. And that's it. And then we need to create .gitignore file, because everything which can be ignored because it can be regenerated should be ignored. So when you work with version control system, everything which can be regenerated automatically shouldn't be included inside version control system. In version control system you should include only your manual hard labor. That means in general it is everything here in src main Java, but only this would not be enough, because if somebody would clone this project it would not be proper Maven project. So you also need pom.xml file and many other things to get it workable. And therefore it's easier to say what should be ignored than what should be included. So I can add new file called .gitignore. Something is wrong. I think this is proper one. And it already says what we should ignore here. So it ignores specific files for IntelliJ IDEA settings, specific files for Eclipse settings, temporary locking files, logs, and etc. And when you create this file, don't get confused that you create it and you don't see this file inside this Package Explorer view of Eclipse, because the default setting is that Eclipse do not show hidden files and folders. And you can go here in ... view menu, filters, and then you can unclick filter dot blah 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 resources or hidden files. Then you also see .settings, .class, .projects, which are setting files for Eclipse, but you also see .gitignore file as another hidden file in this project. And then, before we do any commits, we should check our configuration. Not everything is checked, only these things which can be checked are checked. But everything which can be checked here is green for me. Git global.git file looks okay for me. That means this configuration file .git config, this one. Then .gitignore file looks okay. That belongs to a particular project, so do not mix them up. .git config is in your home folder, which is global setting for Git. And then inside your project, is workspace. We have .gitignore, which is a list of ignored resources for this project. And then remote repository also looks okay as far as JUnit can tell. So if it looks okay, it doesn't mean that everything is okay, but there are at least not fundamental stupid mistakes. If there are some mistakes, these are more elaborate, which cannot be checked by JUnit test. Then you can you go to your repository in terminal and say git add, and dash capital A means add everything which not ignored, created files, modified files, etc. And you'll see that the following things will be included. Before that I don't need the Java dots anymore. This looks better. And then you can commit it. Git commit. And if you do not add message, text editor is added, and following list is generated to you, and everything which starts with hash will actually not be added into this commit message, but you can use this as a reminder and a template what you want to write in non-commented lines, like and then you can push, and you can just say git push origin master. And what does it mean? It means following. Our remote repository is called origin. That's how we named it when we created this link here. Git remote add, name origin, URL is following, or address in jargon. And when you push, you'll have to say on which remote repository. You may have more than one, and its branch. And the default branch is master. Depending on what kind of local configuration you have for Git, it is not required to say everything here, but safe way how to say it independently of your local configuration is to say everything. And then -u means make it as an upstream, but in general that means make this remote repository and a branch for this remote repository as a default one. So if you will just do git push, after that it will always push to a remote repository called origin and branch named master. And you should see something like this, that it's sending data, showing some progress here, and when you write git status, then you should say following. Your branch is up to date with origin master. This means remote repository and its master branch, and nothing to commit, working tree clean. So that is minimum amount of required activities you need to do. What else you can do? First, you may use integrated development environment, and this Eclipse already has a plugin called egit to work with Git inside Eclipse. So you go to window, show view, actually start with perspective, open perspective, other, and choose Git. And then, similarly as adding projects, we have to add references to these local Git repositories. And we add the existing local Git repository, which is located in my workspace here, this one. And then when I have added it, then I can use it in many different ways. We can see what are remote, what are, for example, history of this project, etc., etc. But in most of cases, if you do not need advanced configuration, compare things, etc., you mostly are interested only about this tab called Git Staging. So staging is this index page or scratchpad where you see what you can add as a new commit, etc. So when you have configured this entry to your local Git repository, my recommendation is switch back to Java view, and if you want to use integrated development environment, here go to window, say show view, other, Git and Git staging. And if it happens that I have some changes somewhere, like, I do not know, source, format, source, and Alessia, do you want to ask something? So I have one changed file here after automated formatting. I can compare differences here in this comparison editor, and I can add it, add some commit message, and if I'm always connected to the internet, I can commit and push. Or if I'm not always connected to the internet, let's also organize imports, maybe something will change. Yeah, we can remove these debuggings here. And we also don't need this main method. So LuckKnight again here is used as a library. It doesn't have main method, but it's called from other classes which have main method. So then I can say something like and then I can say only commit. If I say only commit, I updated my local repository, but I didn't synchronize it with remote repository. And here we have one problem, because as far as I can tell, I'm not super user of this Git plugin. But one important thing what I cannot easily to do in this integrated environment is to see status easily. Because if I use command line client, I see two different kind of information. First is, do I have some changed files which are not committed. For example, I don't know. What would be? Something like this. So I also see that here is changed file and differences are following. And in command line, I see that this file is modified, and with git diff, I see what exactly is modified by this file. And I can just say git add, for example, src. And then I don't see anything about modifications anymore. But so here, when I see two different kind of informations, what is my workspace status or my files and folders according to the local repository, and here I see that everything which is included in version control is stored into local repository. No new changes which are not committed. That is this line of output. And other line of output is status of my local repository regarding to remote repository. And I see that my local branch is ahead by 2 commits regarding to remote repository named origin and its master branch. And if you work like me and you do not push all the time because you do not have reliable connection to the internet or whatever, or you like to use this feature of Git version control system that it's distributed, you don't need always connection to the internet, then for these other tools I don't see this very important piece of information that I should do also push from my local repository to the remote one. And the same problem is also with IntelliJ IDEA. Only, of course, details are completely different. So IntelliJ IDEA here is much more user-friendly. Eclipse ignores everything which can be ignored, and it doesn't ignore only these things which you say to not ignore, like adding something to Eclipse entries. It may be not so user-friendly or developer-friendly, but good thing is that because of that, Eclipse is much faster, because it does only these things which you explicitly ask it for Eclipse to do. For example, if you didn't say for Eclipse to start caring about this local Git repository, it doesn't care about it, so it works faster. But IntelliJ IDEA, similarly to NetBeans, always is scanning your project in the background to discover new things and new features in your project, so it makes it much slower. Why don't I see? This is strange view what I see here. I'm on. Let's check that I'm on proper project. I want to look on this project here. So, and then it automatically knows that if you have created a local Git repository with all its configurations and entries, so you can just go to, but I need to make some changes here. It is hiding too many things. Because I have changed this folder here, so how do I go back to here? Okay, this view is good enough for me. So let's make some changes. Okay, let's remove some more hints here as well. That is something wrong. Does not belong to the project. As far as I could tell, usually IntelliJ IDEA allowed me to edit projects located somewhere else. But now its behavior has changed. So, and then you go to Git and just go to commit. And you see here in double click what are differences if you need to compare, and then you can add it to the commit, add commit message like, and similarly you can only commit and push. Again, if you choose just to use commit, which works much faster because you don't need connection to the remote repository and connection to the internet. Again, as far as I can tell with my knowledge of IntelliJ IDEA, again, I can't easily see this very important status that now I have even 3 commits ahead on my local repository regarding to the remote repository. Of course, if you have some other changes here, for example, remove hints again and commit and push, of course I will push to remote repository. But I don't like these integrated tools because they hide, at least in my opinion, one very important piece of information: what is status of my local repository regarding to remote repositories. And how I find it out is some students were very worried in some previous class that I didn't test their progress correctly because it happened that they didn't push everything what was needed from local repositories to remote repository. So don't be like that student. Always check. So for me, command line client is much easier because in different kind of projects this development environment may be very different, but command line client works in the same way in very many different projects. And I don't check it how it looks like in NetBeans for very long time, so I don't know what has changed in NetBeans since I used it last time. I did that from this new virtual machine, probably not in this one. So again, we could change something somewhere. And I'm used to how quickly it works for Eclipse. And if I can open some tree here, then I just double click and it will immediately open it in editor, but not so fast in other editors. Here some to do is still left. I think it was somewhere in Teams, diff to hand, these are differences, repository, let's check configuration. So this is actually, NetBeans here works similarly as for these automated tests. Here instead of elaborated graphical interface, it just opens this file in editor. So all configuration for Git local database is located in .git folder config file. So we see this config file here in NetBeans. So then we can check what are our differences. So I removed this to do. But how do I add commit to it? I don't know. Commit, similarly to commit. And how do I push it? With separate entry, so I can push and see. Push to upstream means push to this remote repository which is made local, and how it's made local, it's inside this git config file. And again here, as usual for such tools, I don't see status very easily, what I have changed, what is not committed in my local repository, and what is difference between my local repository and remote one. So all these three tools are sick with the same illness, with the same problem. Maybe they do not consider this as important as I am considering it. So that's about integrated development environment. Of course, integrated development environment is nice, but you should know at least something about theory and terms to use exploratory testing to understand what exactly you need to do here in these menus here. So that, I think, is it for me about this particular exercise. Do you have any questions or comments?